Hello. Tick, 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 tick. Yeah. For sure. Ay, sir, बना sir. Sarvana sir, please go ahead with starting. Sarvana sir. Sarvana sir, please go ahead with the profile of sir, and please disconnect your video. You can proceed with your audio only because your net is creating some issue, I think.
Here, sir, my voice.
Your voice is clear, sir. Now you can proceed.
A warm and glad welcome to everyone. Myself are Sarvana Kumar, Assistant Professor, Department of Mechanical Engineering, Noida Institute of Engineering and Technology. We bring to you this morning filled with desires, hopes and dreams we all share. The final day of 5-day faculty development program on additive manufacturing and industrial scope and applications, sponsored by AICTE Training and Learning Academy, organized by Department of Mechanical Engineering, Noida Institute of Engineering and Technology. We will start with the first session by Dr. S. Ramanarayana Reddy, Indira Gandhi, Delhi Technical University for Women, Delhi, in the title of Design and Innovation Ecosystem Towards Electronic Product Design, a novel methodology for higher education towards Make in Lab 1. Followed by the second session also by Dr. S. Ramanarayana Reddy in the title of Design and Innovation Ecosystem Towards Electronic Product Design, a novel methodology for higher education towards Make in Lab 2. So Lab 1 in the first session, Lab 2 is the second session. Both sessions we have an eminent speaker with us, Dr. S. Ramanarayana Reddy. I welcome you, sir. I would like to share some points about Dr. Ramanarayana Reddy. Dr. S. Ramanarayana Reddy is working as a professor in Computer Science Engineering Department of Indira Gandhi Delhi Technical University for Women, Delhi. He is currently acting as a Dean Examination Affairs, IGDTUW, that is Indira Gandhi Delhi Technical University for Women in Delhi. He was awarded PhD in the area of embedded system design in 2009 and MTech degree in 2002 from Jawaharlal Nehru University, New Delhi. His research interest includes engineering education, embedded systems, design, mobile architecture and programming and Internet of Things, IoT. He has published more than 80 research papers in various international journals, conferences, and published couple of books also. He filed an Indian patent along with his research team and collaborators and transferred the patented technology in the title of My Smartphone Kit to the industry for commercialization. He is a PI in 6 extremely funded sponsored projects by Microsoft, Intel and Nokia, and COPI for 2 MHRD sponsored projects in collaboration with IIT Delhi and IIT Delhi, and completed 6 projects successfully. He established the state-of-art embedded and product design and IoT Innovation Lab in collaboration with Microsoft, Nokia, Atmel, ARM towards entrepreneurship. He has received several equipment grants from Intel, Nokia, Microsoft, ARM, IT, to name a few, and received international travel fellowship from Intel twice. He has conducted more than 50 workshops, training programs on mobile architecture and programming, IoT, design and development of smart devices for industry, faculty, and students. He has conducted few tutorials in the national and international conferences and delivered several expert lectures, keynote sessions. He has more than 20 years experience that includes research, industry, and teaching. He is a member of CSI VLSI Society of India and AMIE, and guided several MTech students and PhD students. He received the fellowship from Intel to visit and present the work in USA and Taiwan. He also received an award from Intel for his contribution and promoting technology in higher education. He was one of the founder directors of IGDTUW Ambition Foundation, Section 8 company, and acting director of ETI Lab Private Limited, startup company at IGDTUW. He has published several course development manuals along with the research students. I am very happy to invite you, sir.
Thank you for your kind introduction. So, may I share this? Allow me to share my presentation.
Sure, sir. Please share, sir.
Okay. Am I audible to you?
Yes, sir. You are audible, and your slide is also visible to us.
Yeah. Thank you very much. A very good morning. I think in front of Diwali, I must congratulate the NIET team management for organizing such a wonderful event.
It's our pleasure to have you here, sir.
Thank you so much.
Always great to hear from you, sir.
Thank you so much. And I would like to make this session a little interactive. And if there is any questions or any suggestions, anything, you please chat with me or stop with me in between and ask me the questions so that we can have not very formal presentation or discussion. So we can have a very informal way of taking this session forward. So with this note, since I've been doing working with Indira Gandhi Delhi Technical University for almost 20 years, had several responsibilities and very main primary role as a teacher of computer science department. I always wanted to have a practical approach in teaching, learning, and experimentation. And that kind of intuition made me to work towards product design, innovation, and ecosystem. Fortunately, we had a very good mentorship and ecosystem in order to do, and therefore we have started the state-of-art facilities in the university. Almost spent around 15 years in order to get into this particular state-of-art facilities, and as a result, we've been able to make some products successfully and deploy, and also several products are in the pipeline. So I wanted to share my experiences, how one can able to do so. And if you wish to achieve or if you wish to work in this particular area, what is all you need to have and what kind of ecosystem one should have. So this is my primary task, and I will be covering you a little bit about the methodologies that we have followed, the infrastructure and discussion, and also some live demonstration or the videos, and some showcasing the outputs of various product designs that especially done within our laboratory facilities. So with this, let's brief about and some learning objectives, ways to create innovation in product design and IP are also a little bit I'll touch upon. Then novel methodologies, examples and case studies, challenges and recommendations, and finally we will have question answers. So I will be combining both the lectures because it could be very difficult for me to segregate because of the connectivity of the topic. So let me know if you have if you want to have a break in between, we can have, and then I'll continue that. Now, let me put some questions. See, I always know when we need to have a product design, it is the everyone cannot do the product design. You need to have a complete ecosystem, and you need to work from out of your comfort zone, and you need to be a very resource facilitator and also good learner, and also should have a very good ecosystem, which I will be going to explain. But you need to have some of the questions and you should be able to answer these questions. So the first question I would like to take up: can I design electronic products and scale it? Working in the university with full responsibility as a professor in the department, dean examinations, head of the department, can I able to do that within this time frame available to me? I'm sure that though those responsibilities takes me away to an extent, but yes, I always prefer to go for teaching, sharing the experiences and learning from the people. So we could able to make it in spite of having certain administrative responsibilities working for quite long time. The next question you need to put yourself: can I create the workforce productively to serve the end users? So for example, we are all, I am sure that mechanical department has come forward, and we work closely with the mechanical department of IIT Delhi, and we actually learn many of these product designs from them. So when I say that I saw this mechanical department organizing this event, it is very nice that the department has come forward to make such kind of wonderful things. I only urge the department and the staff of NIET to have little more practical aspects and showcase the outcomes of your lab, our university, or your department to the outside world. I'm sure this session could at least give you some kind of insights. So we all as a faculty members should be able to put ourselves a question that am I able to produce such a workforce where my students could able to produce the product designs while they are in the university or the department, or when they go out of the university. Then how to plan to make the product design. So what kind of planning you might need to make this possible? Then what are the requirements? Finally, of course, when you make the planning, then what kind of infrastructure does it require so that you can fulfill your dream? Then finally, can I able to make my product design possible within the lab so that I finally bring it to the end users? Answers to these questions is yes, and I'm going to answer all these questions which we have done in the university and showcasing you one by one. The first thing, probably I try to organize the slides. I've been almost spent 15 20 days what should be taught in this case, so I just pulled it and created some slides especially for this, and gathered some information which we've been doing it, and try to organize the way I felt it appropriate. So the first thing I want to make you know, we have fortunate to have one good project from MHRD in collaboration with IIT Delhi, wherein we could able to create a good infrastructure within the lab. So this is all the actual products which are available at present in the university, wherein I am able to produce an electronic product, start from PCB design, and finally going with the end product out of the lab. So therefore, I may be starting with PCB design, then PCB manufacturing, then I need to make the pick and place, reflow woven, stencil printing, and then finally I might be using the laser cutting or 3D printing for finally showcasing the end user products, the way it should feel, aesthetics to the product, and color to the product, and so that when I design it, it should feel that this is a industry driven kind of project. And therefore this is the infrastructure is very essential, and I'll be covering a later stage and showcasing you how we can use these facilities to make some of those products as per the time limit. I try to cover you, and we have created each and every product out of this, some manuals, some training programs, some hands-on sessions for our own research staff and also our own students, so that they can use these facilities. I might really request you, whenever you get time, to visit our lab, and we will be going to do more hands-on session, make yourself and take yourself. Such a kind of concepts we are coming up, so that not only our own people, but many other institutions should be able to get the benefit out of this kind of facility which we have created. So this is especially for electronic product design, and I am sure that we say electronic product design, there is a lot of products comes up with mechanical hand to hand, and we also need to learn in interdisciplinary areas, and therefore this is not just only a computer science or electronics or mechanical, it's really a mixed kind of environment. So that is what one thing we need to do, and I just want to, what kind of methodology one has to follow in order to achieve the product design. The second question, I answered the first question, what infrastructure do you need to have? Maybe the questions could be ordered in different way. What kind of infrastructure at least you need to have? I have shown you for electronic product designs, at least this is a basic infrastructure that is required. Then what methodology one has to follow if you wish to have a electronic product design? First of all, you need to have an idea what to build, which product you need to have. And this has to, there are several ways how you can able to ideate the product, ideate the design. I'll be covering in few slides later. So the first thing is you need to have the idea. And the second thing, once I have an idea, then I need to go for being electronic product design. I just focusing it. Let me do have a PCB design. So there I may have several options for PCB design, several free and open source and proprietary softwares are available. So I can pick up either of that, and I may design the PCB, simulate it and test it, and may get some samples manufactured either in the lab or outsource that. So that is what the next step that one has to follow. The third step is PCB manufacturing. So we may able to manufacture the PCB by using the PCB manufacturing machines. But if you need to have initial for testing and verification, you can do that. But if you are going for a mass production, we try to ship it to the third party where you will be able to get very finest manufacturing of those PCBs, maybe single side or double side or multi-layer PCBs as per your requirement. So once PCB manufacturing is, there are several vendors. It's very easy today in comparison with earlier times. So you can able to make with the little efforts this kind of facility. Now, assuming that I got a PCB manufacturing done, now I need to manufacture and produce, let's say, 100 to 1000 products of similar nature. Now, how do I do that? So I may need to go for in manufacturing of these products. Then the next thing that I required is a stencil printing. So stencil printing, as I shown you in the previous pictures, and I'll also going to show you some video how you can use the stencil printing. So stencil printing is a kind of mission or a device wherein you could able to paste the soldering paste on the PCB, so that further processing can be done easily. So once this is done, then I will be going to keep this my PCB into the pick and place machine, and I will be going to show you how pick and place machine is going to work, which is available in our lab, and stencil printer also available in lab, and PCB manufacturing we have it in the lab, but I could not able to show you with the PC with the video. Let me see this if time permits. Then once what the pick and place machine is going to do is, all the components of electronic devices are coming up as a feeders in the tape, in the small magnetic small plastic tape, and through the feeders this machine is going to pick the components and place it in the PCB automatically, and this is one of the nice facility which you can use it. And then once it is done, the PCB where the components have assembled, now you need to take those components, assembled PCB, to solder it. So either you can use the normal soldering, but since the SMD based components are very small in size, so you need to go for a reflow oven where the products undergo into a oven, and the paste is applied, soldering paste is applied, and due to the solder paste and heating has been done, and therefore wherever there is a lead and heating has been done, and that particular area the components will be soldered automatically, and finally the product come out of from the shoulder, and then you need to do the outer surface. So you may have go to the laser cutting if there is some kind of casing has to be done, or some kind of product design has to be done. For some holes you need to make it on the casing, so we may use the laser cutting machine effectively. And then finally if you want to do the very good 3D modeling, we will go for 3D printing, and then the entire PCB is going to house it in the 3D printer, and then finally you will be going to see the product out of this. So there may be different methods, different tools, and different devices, and different. There's be many more, and many people might be using in different other missions as well. But I am going to use, I'm following it in this kind of approach in our manufacturing facilities in the lab, and I just followed whatever the method we are being following. Try to put it in an easy way of understanding. So therefore, finally the product is out, and then it go into the testing and it verification, and a lot of other product manufacturing cycle goes in that. So primarily you need to have a 8-stage process, ideation to the 3D printing. Of course, certain things you can do not necessarily in the sequence. 3D printing and laser cutting you can even do with parallelly with other things, so that you can able to house it. So I thought of giving you a glimpse of the steps that has to be followed in product. There are many more steps, but I try to cut down as much as possible where you can able to understand. Now, the important question that I was trying to answer you, what is the key parameters for product design and creating the IPR in the university or in the department? Suppose if I want to design, what kind of principles, what kind of parameters that I need to keep in mind? So whenever you go for, because when you design the same product, though nobody would like to buy, and nobody would like to accept that. So there should be some kind of novelty in the product design, in the product itself, and therefore novelty is very important when you need to make a product successful. Say due to COVID-19, there are several products has come up in the new design. Suppose assuming that if there is any chance that new viruses are coming up, then the new products has to come to meet out the requirements. So therefore, there should be novelty in the product design, and that should be accepted by the user. So that is the one thing has to keep it in mind. Then there should be industrial applications. So the end user has to accept that products, and it should not be the same product as others are being used, and there should be a innovative way, and it should serve the end users requirements. And these are the three important parameters one has to keep in mind when you are going for the product design and creating the IPR out of it. Now, how do I do that? This is the main. So I know that this is a methodology, and I know that these three things has to be keep in mind. But then how do you generate the ideation, a new idea? How could you get so that you can design the product? I think I do not know what people have been following it. Some of the best practices which generally being used and what has been used by us for almost 15 years. I just highlighted those things in order to make you so that I think the one and very important thing is that field visits and observations. I think how do you get a innovation or new product design? Many cases, one approach is that you might be visiting some places and you observe that there may be some problem. With that, you try to make a solution, and this is the one way which a product design and innovations can be done. So by using this method, we have two innovations that we have done, and that I'm going to discuss it a little later. So one approach is that you must need to visit the outdoors, maybe indoors in some places, and observe the things what people are doing and what problems they're facing, and try to provide the solution for that. Then conceptualize solutions to the problems faced. So I may be a teacher teaching a particular subject, let's say mobile computing, or for example, even you take it as a product design. Now I want to have a single automated way of integrating various facilities in a single mission with a single software so that I can able to do the complete product design. If I am taking a course and I need to have such a mission, I may be designing, and this is my requirement, and therefore I am facing the problem, and therefore I may be able to design the product. So I wanted to tell you here, as a teacher teaching embedded systems, I wanted to have practically teach the concepts, and we have created several evaluation boards in order to bring the practical aspects among the students. So through this approach, we could able to make three innovations or three product designs. The next one is interaction with students and collaborators. So somebody comes up with some problem statement to you. So when you are discussing with some students, be it a major project or minor project, or you may be discussing with some maybe collaborators with some third-party vendors, and they may bring it, Professor Reddy, I have this problem, can you be able to help me? And that is how you can able to get another way of product design. So this is another method. Then student also brings sometimes innovations, and you may be mentoring with them, so that this way you will be still able to get it. So we have made almost 8 patents so far. Out of 8 patents, 2 of them is just because of the field visits. When I go outdoor education, and I will be able to get some problem statements, and therefore I conceptualize. Then as a teacher myself, I've been facing some problems and I wanted to bring the solutions for that. And therefore, three product designs we have made in that direction. And some of these interactions with some requirements to meet out. And then some of the students bring up their own innovation. So you conceptualize that and finally translate it. So therefore, we could able to make 8 product designs and 8 patents out of that. Some of them I will be covering as an examples and case studies. So, dear friends, I do not know any other methods are there, but what has been followed and what has been done at our place, and I try to organize and bring it to you in this way. So you may think of any of these methods of 4 ways which I have mentioned uh, could lead to you a product design. Any questions?
Sir, no questions so far.
Okay. So if I wanted to go through that, what kind of products out of this? What are these products are all about? So I think you could see that in the first one, smartphone kit. I think this is one of the novel thing which we have done. Say, think of in 2010, 2009 or 2008. I think that was an era of small mobile phones. And I've been teaching a course on embedded systems in those days. My PhD is in embedded systems design. I've been awarded in 2009. After my submission of PhD in JNU, I had a 3 month summer internship done with IIT Delhi under Professor M. Balakrishnan sir. He has invited for solving some of the problem of FPGA virtual labs. But I went with some proposal, sir. I wish to have configuring the mobile phone to teach the embedded systems. That was my proposal. I went with the proposal and discussed with him, and he said, "It's fine, Professor Reddy, you please go ahead." So I still remember in 2009, June, July, August, I mean May, June, July, I spent completely 3 months time every day 9 to 7 or 8 p.m. Though it is not my requirement, it is only my interest and my interest to solve my problem. What is my problem? My problem is that I've been teaching embedded systems course for UG, PG, PhD students at that point of time. But whenever I wanted to teach, it is very, very difficult for me having a board, having a tool chain, having a operating system and all capabilities. Very, very difficult to have a compatibility, to integrate each one of them and have a learning materials. It is very difficult and it is very expensive also. Approximately, if I need to have 1 unit of that, it might be costing somewhere about 1 lakh rupees. Now, if I wanted to ask the university, it is very difficult to get it arranged. Now, I thought by the time if I have a mobile phone from Nokia those days, which was costing about 5,000 rupees to 7,000 rupees, maximum 10,000 rupees if you go, which has a very bigger size display, which has a good ARM processor, operating system, all peripherals that is required for teaching embedded systems. Then I thought, why I need to spend 1 lakh even more than that for teaching embedded systems with 1 unit? Why can't I use my smartphone itself or mobile phone itself to teach embedded systems course? And that was my problem. And all the time I was teaching through simulations and I was not happy. To solve my own problem, I went with this proposal, and fortunately IIT Delhi sponsored 11,000 rupees to buy a new phone. We reverse engineered it and find out by using a Python as a programming language, Not only embedded systems I can able to teach, we explore to teach each and every subject practically by using that. I could able to port my operating system, new OS. I can able to uh, interface each and every peripheral, and this is opened a new avenues for teaching practically in a low cost open source environment. With that outcomes, we wrote a proposal to Nokia, and as a result, three projects from Nokia worth 1 crore rupees approximately has been received. Almost 100 plus devices has been received at different instances of time. At least 50 different workshops and training programs on this has been created. Two books has been written, new courses have been created. Really, it has opened a new direction, not only for us and many more people. We serve and we share the knowledge and learning experience. Dear friends, if I come across my own problem and keep it with me, I would not have done it. But other important thing is, if I need to serve such a scale, uh, I have to sacrifice many things, and there are so much of team, lot of efforts, of course, has to put. I think without any pain, there will not be any gain. So when you are going for a product design, you need to come out of your comfort zone and work on it. And still today, we've been known as Mobile Architecture and Design Lab. Looking our approach, Intel came forward, Microsoft came forward, many more projects have really led us, and we have opened specialized courses on that. And it was really eye opener for us and really created a good path and good career for many students and many researchers in this particular direction. So that was one of the success story, and it led us a one patent technology transfer, and this was one of the first patent we filed in the university and technology transfer and created revenue to the university from the lab. After doing that, the second one, soil sensing kit. So we've been interacting with Intel and we filed the second one. I, as a farmer, family, having the experience with farming, we all the time face the balanced fertilization is very essential. With the collaborations with the research organizations, we try to bring it soil sensing kit because soil sensing was done very rarely, and people put either excess fertilizers or under fertilizers. Both are dangerous and both are cause the losses to the farmers. So therefore, we created a soil sensing kit. I think it was started in 2015-16, and still one student is working towards his PhD. And in the first problem statement, one student has submitted her PhD and working for her final dissertation, Viva. And the third one is aquaculture and monitoring system. I will be discussing that particular use case a little later. And she is also submitted her PhD thesis work and waiting for the Viva. Then recently, one more student working with IIT Delhi. She was our MTech student. She has started her own startup company under this particular patent, and she is creating the visually impaired students a very interactive graphical way of making the different textile books in an innovative way, in a low cost way. Then we have another 4 or 5 patents recently we have done. Those was a blue color, green color one, which was quite old. And recently we have another 4 patents, which is again to solve our own problems or some student innovation. So you could see here problems faced. My own problem statement was there. Then the second one, visits to the fields, soils, and there was an interaction, and aquaculture also visit to the interaction. You could see that What led me to do this product design? This 4 approaches I've been trying to say that. So I tried to cover you a few more in detail, the rest of those things in the presentation. Let me take up. And we are trying for one more IPR, and product design has been done, and she has been awarded PhD recently. She is Miss Shonal, and this is primarily her work during the PhD thesis. This work has been collaborated with RML Hospital, and primarily to solve the congenital heart diseases in newborn babies, a remote healthcare system has been developed. Now, why I wanted to bring here, I wanted to show you a lot of work has been done in the product design, and that wanted to showcase it. Here you could see Swast was the first product. The entire module was 3D printed in the lab. Okay, that was the one of the work primarily done, and several sensors has been integrated in that particular prototype. And since this was a bigger in size, and then the second version there has been reduced it to the smaller size, and the student is getting some data in comparison with commercially available systems in tertiary healthcare centers. And here also you could see that those devices, of course, it has a mobile interface to get the data out of the devices. Then you can see the individual sensor node design has been done. Here also 3D printing is done. Even the PCB manufacturing has been done. So I could not able to show each and every component here. But yes, you could see here the PCB design has been done by the student, and we got it manufactured and assembled the component, and finally the product has been designed in a smaller size and went into a final deployment. So I would like to bring here, we had a designed PCB manufactured. Of course, we could not use the pick and place kind of missions because it was the early stage, and we recently bought those missions and trying to use it. So the learnings here is starting from PCB design, laser cutting, 3D printing, taking the entire product into the end user and serving the final requirements. So all this cycle has been completed, and the student is even awarded the PhD in this particular work. So the learnings is that the challenges here is we still need to design smaller size, operating with low power, and getting the medical clearances, ethical clearances is also one of the thing. So we might be extending this work with some other student during the next 2-3 years time. We may be able to see some kind of commercial product from this particular direction. The second one, as I mentioned in our earlier case, is the aquaculture. So if you visit to the Bhimavaram, that was the coastal Andhra Pradesh, it is known as India's aquaculture zone. I think a lot of revenue, foreign trade has been successfully creating the revenue to the governments is that the aquaculture farming. You could see there when I've been to that particular place in 2015, I guess, 2014, I guess, they have invited me for some international conference as an expert to lecture. So when I've traveled to there, I find that everywhere you will find artificially created ponds where there are aerators are spilling the water. I find that why this kind of situation here is this. Then after the event, I discussed with the professors. They mentioned that this is required due to the aquaculture, and the prawns or fishes which lives in the water needs the sufficient oxygen content in the water. If you want to get the sufficient oxygen content, then you need to aerate the water, rotate the water so that the oxygen in the air dissolves it into the water so that the sufficient quantity of oxygen will be made available. Otherwise, the prawns or the fishes will go die. So therefore, this particular product design has been done, and we have deployed 3-4 iterations. Of course, the final product has to come. The student has submitted and the evaluation has been done, and we are soon conducting the viva for the student to our. So the challenges here is we faced is in the product design. When you keep the sensors on the water all the time, the sensors get more corrosion due to this, and for the data readings actually uh, due to the scaling on the sensors, the sensitivity of the sensors are getting issue, and we are the two major issues we found, and we're trying to address some of those issues in further design. So it was a really eye-opener for us. The devices works in the field, works in the lab, may not work in the field and environmental conditions. I wanted to tell you that when we deployed it, one sensor node, you could see here, tied it to hanger it to this, but it was working around the clock. But at midnight, 12 o'clock, we find that the device is not working. So we went to see that what was the reason, and other three nodes were working and one node was not working. That node was actually not getting sufficient battery backup. We understand why other are getting and this particular node was not getting, because that there was a tree shade stopping the sun falling on the particular uh, surface of the solar panel. As a result, sufficient energy storage is not happening. Then the second problems which we found is that under the tree there was another node. There is a lot of burst droppings as resulted in that the efficiency of the charging circuit is going down. So you never thought of such kind of issues unless you see go there in the field and try to address, and that was a really a learning. So any product design when you start doing, you need to interact with the end users, you need to see the field conditions and then design it. So these are the, of course there are several challenges in this product design which we have faced and try to address one by one and various iterations. So is there any break or should we continue, Mr. Raj?